Hi, in this video we will look into arithmetic sequences for IB. We will start with number sequences. In this example it says find the next three terms of the following sequences. Let's look at part A. 2, 5, 8 and 11. To find the following terms we need to understand the pattern here. 2 to 5 it is increasing by 3, 5 to 8 again increasing by 3, 8 to 11 increasing by 3. If we follow the pattern, we can see that next three terms will be 14, 17 and 20. Let's look at part B. Our numbers are 1, 8, 27, 64. We need to understand the pattern again. 1 to 8 is increasing by 7, 8 to 27 it is increasing by 19. So the pattern should be different than the first one. Let's look at the numbers again. First term is 1, second term is 8, third term is 27, fourth term is 64. These numbers actually are cubic numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So next three terms will be 5 cubed, 6 cubed and 7 cubed. We want to focus on what is an arithmetic sequence. So arithmetic sequences are actually special number sequences, and every successive term is differ by a fixed number from its predecessor. If you look at this definition, we can actually say that our first example A is an arithmetic sequence because there is a fixed term 3 and 3 and 3. However, B is not an arithmetic sequence because the first two terms increasing by 7 and then 19. So B is not an arithmetic sequence, but A is. So look at these two examples here. 1 to 2, 2 to 3, 3 to 4. They are all increasing by 1. So this is an arithmetic sequence. 18, 15, 12 and 9. It is a decreasing sequence, but it is still an arithmetic sequence because it is decreasing by a fixed number, -3. This fixed number is called common difference. IV calls it common difference and it is represented by D. For the second example we talked about, the fixed term is -3, so we can say that common difference in this sequence is -3 and we will represent it by D. If you cannot directly see the common difference as you in here, you can actually use a different method to find the common difference. To do that, you just need to subtract two successive terms from each other. But remember, order is important. So if you take 18 and 15, you need to subtract 15 minus 18, you will find the -3 common difference. Or if you use other two terms in the sequence, 12 minus 15, -3, again, you can find the common difference. 9 minus 12 gives you again -3. So you just need two terms to find the common difference. Let's look at this example. It says, for the sequence given, find the fifth term. We don't know what kind of sequence is this, so we need to find out the pattern first. Let's look at the terms. 3 to -1, the difference is -4. -1 to -5, again, difference is -4 and -4. We can say that this is an arithmetic sequence and common difference is -4. Part B says find the 15th term. To find the 15th term, we can actually write the first 14 terms. I have written them already here. 3 minus 1 minus 5 and 14th term is -49. So 15th term will be -53. However, this is not a very convenient method to find the 15th term. If we can develop a formula, so we can directly find any term we want directly. So part C is about that formula. It is called general term or nth term. To develop this formula, we need two pieces of information. First one is common difference D. We already find out that it is -4. Other information we need is the first term. Our first term is 3. I will write u1 equals 3 because IB represents every term by u. So you can say that u1 is first term, u2 is second term, u3 is third term, and un is nth term. So we want to find un in this sequence. To do that, we can actually develop a pattern. Second term can be written by using the first term 3 and by adding one common difference to it. So it is actually 3 minus 4, negative 1 is the second term. Third term again can be found by using the first term 3, and if we add two common differences to it, 2 times negative 4, 3 minus 8 is negative 5. This is our third term. Fourth term again, first term plus, this time we will add three common differences to it. 3 minus 4, 3 minus 12, which is negative 9. If you look at this pattern, we always add one less number of common differences to the desired term. So fourth term, we added three common differences to the first term. Third term, we added two common differences to the third term. So if we follow the pattern here, un equals first term 3 plus one less number of common difference, which will be n minus 1 times our common difference is negative 4. So we can simplify this formula. So 3, if we distribute this minus 4 in here, it will be minus 4n plus 4. It is equal to 7 minus 4n. This is the nth term. Let's check if this formula works or not. Remember, we found in part B u15, 15th term, as negative 53. Let's substitute 15 in our general term and let's see if we have the same number or not. So u15, if we use the general term formula here, 7 minus 4 times common difference is 15, 7 minus 60, and it is equal to negative 53. As you can see, the formula works. General term or nth term formula will be given to you in the IB exam. It will be in your formula booklet and it will look like this. un equals first term u1 plus n minus 1 times common difference. Let's look at this example. For the sequence here, negative 7, negative 2, 3, is this an arithmetic sequence? Verify your answer. If this is an arithmetic sequence, there has to be a common difference. Let's see the relation between the terms. Negative 7 to negative 2, the change is actually 5 units. 2 to 3, again, the change is 5. 3 to 8 is 5. 8 to 13 is again 5. So we can say that yes, this is an arithmetic sequence and common difference is 5. Part B, find the general term. So general term formula will be on your IB formula booklet. So it is un equals first term plus n minus 1 times common difference d. So in this sequence, u1 is negative 7 plus n minus 1 times common difference is, we said it is 5. So negative 7 plus 5n minus 5, which is equal to negative 12 plus 5n. So this is our general term or nth term. Part C says find the 100th term. To find the 100th term, we just need to substitute 100 to our general term formula. So we already found that un equals, I will quickly check, minus 12 plus 5n. So if we substitute 100 into the formula, we will have u minus 12 plus 5 times 100, and it is equal to minus 12 plus 500, which is equal to 488. This is the 100th term. Part D. are 818 and 1230 of the terms of the sequence. To find it out, we need to use our general term formula and check that is there a value of n gives us 818. So if we substitute 818 for un and if you isolate n, 830 equals 5n, and we find n equals 166. So yes, this term is actually part of the sequence and it is 166th term. Let's do the same test for the next number, 1230. Is there an n value such that gives us 1230? If we move minus 12 to the other side, 5n equals 1242 and n equals 248.4. Every term number must be an integer, not the value itself, but there is no 248.4th term. It is not possible. So this number 1000. Let's look at some of the exam type questions. Question number 1. Find the first term and the common difference of the arithmetic sequences that have the following nth terms. un equals 4n minus 5. We can substitute 1 in the formula and find out the first term. So u1 equals 4 times 1 minus 5. So 4 minus 5, the first term is found as negative 1. If we substitute 2 to find the second term, 4 times 2 minus 5, so second term 8 minus 5 equals 3. So our first term is negative 1 and the second term is 3. Since we have two terms, we can find the common difference. Negative 1 to 3, the change. Question 3. Find the number of terms in the following sequences. Let's look at the first sequence, 6, 10, 14, 18, up to 74. If you look at the relation between the terms 6 to 10, 10 to 14, 14 to 18, you can see that there is a common difference 4. So this is an arithmetic sequence and common difference is 4. First term is 6. We need to use the general term. So what is the general term? un equals 6 plus n minus 1 times 4. If we simplify this formula, 6 plus 4n minus 4, and general term becomes 2 plus 4n. So, which term is 74? That's the question. So 74 is actually our un. un equals 74, which is also equal to 2 plus 4n. Again, we are trying to find which term is 74. 72 equals 4n, n equals 18, which means 74 is actually. Question 8. The sum of three consecutive terms of an arithmetic sequence is negative 27 and their multiplication is 648. Find these terms. Because this is an arithmetic sequence, every successive term differs by a fixed number, common difference. So if we say that first number is a, second number will differ by one common difference, a plus d, and the third number will be a plus 2d. The reason is if we add another d to the middle term, it will be a plus d plus d, a plus 2d. Now, we have the information of their sum is negative 27. So if we add these terms up, we will have this equation, and then we have 3a plus 3d equals negative 27. Now, we can simplify this by 3. So we reach out that a plus d equals negative 9. This is the first information we have from their sum. Now we have their multiplication information, which is 648. If you multiply these three terms, just like this, a times a plus d times a plus 2d equals 648. Look at in here, we already found that a plus d is negative 9. So we can say that a plus d is negative 9. If we substitute here the negative 9, because this is an arithmetic sequence, if the middle term is a plus d, previous term will be negative 9 minus d. So it will look like this. previous term will be negative 9 minus common difference, and next term will be minus 9 plus the common difference. So the multiplication of these three terms is equal to 648. Now, multiplication of these three terms here is 648. We can simplify negative 9 and 648, and we will have minus 9 minus d times minus 9 plus d equals negative 72. Now, look at this multiplication. This is minus 9 minus d, minus 9 plus d. Remember that this is actually difference of squares. So a minus b times a plus b equals a squared plus b squared. Now we will use this identity to solve this equation up. So if we write the equation again, so this will be minus 9 squared minus d squared equals minus 72. Remember, we reach here from here by using this identity. Now, we have this equation and it is easier to solve now. Minus 9 squared is 81 minus d squared equals minus 72. D squared equals 144. Now we have d equals either positive 12 or negative 12. This means we will have two solutions. Now, if we go back to their sum, a plus d equals negative 9. If we assume that d is negative 12, and if we use this equation, so we will have a minus 12 equals minus 9 and a equals 3. If we have a and d, now we can write these three terms. They will be 3, minus 9 and minus 21. If we assume that d is positive 12 and follow the same procedure, then we will have these terms negative 21, negative 9 and 3. These slides are created with part of a digital textbook. Only some of the examples and questions appeared on the video. The book has 9 sections and covers number and algebra unit. The book is created with minimalist design language, easy to follow and easy on your eyes with its dark theme. This is an interactive textbook. Other than written explanations, every section has video tutorials. All you need to do is click on video boxes and start watching. At the end of every section, you will find exam type questions. These questions directly prepare you for IB exam. They have written solutions as well as video solutions. Solutions are prepared in detail to make your understanding easier. You can purchase the book through Apple Bookstore and it works on your iPhone, iPad and Mac. The link is available in the description below. Thank you for your support and I wish you a great success in your IB adventure. See you in the next video.